So, hello and welcome to lab number 2. Today we are gonna work on the response of the temperature measurement sensors and see if they actually follow the behavior of the first order system or not. In order to do so, in part 1 we will use thermistor. This is our thermistor, and in part 2 we will use thermocouple. So for part 1 we have to build a circuit. We make use of the circuit board of ENME to do so, and this is the input section, this is the circuit board. First we plug in the thermistor to the channels. These are the channels, as you know by the last session. One side to the plus channel, the other one to the negative. Then by looking at the circuit, we know that we need a positive 5 voltage. We make use of these small connectors to make 5 voltage. Look at here, we have positive 5 voltage, minus 15 and positive 15. We want positive 5 voltage. So we, at the bottom, we connect this one to this positive column, like this. Now this whole column is positive 5 volt. And also we need a ground here. So we connect the ground to this negative column, like this. Now this whole negative column is a ground. And again, by looking at the circuit in this figure, we will see that the negative side of the thermistor should be connected to the ground. So we find the negative sign and connect it to this negative column, which is representing the ground, like this. And the resistor, 10 kilo ohm resistor, will be connected to the positive 5 volt and the positive side of the thermistor. Like this. Now our circuit is created and ready to use. We go to our VI, we open up a blank VI. On a block diagram window, we right click as before, go to express menu, input, bring a DAC assist block to the block diagram. We want to acquire data from ENME. We want analog, we want voltage, and we are working with AI0, analog input 0. Hit the finish button. Again, we know how to work with these settings by now. For the sake of argument and to save some time, we get data for 5 seconds, so we make it 5K. And if we want more time, we have to make sure that this timeout is more than the time that we want. And that's it. Hit the OK button. We want to show the result on the waveform graph. So we right click on the front panel, bring a waveform graph. We connect the data, we wire it to the waveform graph block like this, and hit the run button. I also hold it with my finger, hold the thermistor with my finger to see the result. Now this is the result that we have. This is the voltage and this is the time. Now we want to model the temperature as a linear function of voltage. To do so, we need 2 pairs of data, time and temperature and voltage. So just for sake of argument, let's go with room temperature and body temperature. We go to express menu, arithmetic and comparison, and bring a formula box in order to make that formula. Our variable is voltage V. We change the label to V, and we have to now make our formula. I made it with just 2 numbers. As I said, room temperature and body temperature. We have something like 98.6 minus 75 over 2.07 minus 2.42 times V, which is our voltage, minus 2.42 plus 75. So this is just linear interpolation of 2 points. Hit the OK button. We need another waveform graph to actually show the temperature. We wire the data to the V of this formula, which is input of this, and wire the result to the waveform graph. And you can also hit the Control U button to make it nice and neat. Now hit the Run button again. Now this is our temperature and this is our voltage. So this is for part 1. You have to redo this experiment with a couple of more temperatures. That's it. Part 2 is much easier. We work with thermocouple. We don't need these circuits anymore, so we just disassemble it. Again, we put it in one of these channels. Let's say channel 1 this time, one of them to the positive and the other one to the negative. Like this. And in the VI window, we delete them all, we don't need them. Again, go to Express menu, Input, Deck Assist. We want aquarius signal, analog. This time we work with temperature directly, and we want it from thermocouple. This time we are working with channel 1, AI1. Hit the finish button. This is the thermocouple setup. As you can see here, we can set the unit. We want to work with Fahrenheit. Minimum is 32, 150, and since our NIFS does not have the built-in CJC, we have to make it a constant. CJC is a cold junction compensation because the thermocouple actually measure the difference between 2 temperature and 2 voltages. So we make it at the room temperature, 74 degree Fahrenheit. Again, N samples, 5K for 5 seconds. Again, remember that if you want more time, which you will need, you go to this advanced timing menu and change this time out to 50 seconds, something like that, and hit the OK button. Wait for building a VI. Again, we want a waveform graph to show the data. You wire the data to the waveform graph, and that's it. Hit the Run button. Pause it. So this is a tricky. I don't know what's the problem. I think our thermocouple is not working properly. You see what happened here?
5,000 degrees Fahrenheit.
Yeah, but if I play around with this coating here, things get better. So I think these are not working as they do. So this is our waveform graph from the thermocouple, and that's it. You have to do it for other temperatures, your hand, bucket ice, and room temperature, I think. Good luck with your lab.